And welcome back. As we've been talking about multi-dimensional arrays and arrays, the book in Gaddis has tremendous amounts of examples on how to manipulate and summate rows and summate columns and do some fun stuff. There's not a lot of point in going over that unless you really don't understand it and need some more help. Just let me know. But what we're going to talk about now is this concept that we've got going on of an array having a fixed size. So when you have an array, nums, you have to tell it how big it is, either by explicitly giving it a list of things or by giving it a constant size. If you recall, so our arrays basically have to be done to a fixed amount, which is not a bad thing if you know exactly how many things you're going to get. So in the case of a class, when you know you're only going to have 10 grades or you're only going to have 15 students, you could come in here and put in a constant and fix it in. Well, but what happens if those change? What happens if, oh, you have 16 students? Oh, we have 9 grades now instead of 5. We have 22 students. Oh, if things keep changing, constant fixed size things are not the best way of handling some of this stuff. So there's a concept that goes on. It's basically part of the standard template library of using something called a vector. A vector is a library that was given to us by the programming gods that says vector. And a vector basically you can think of as an unbounded array. It doesn't have a size limitation. So cases where you might want that. You're reading values from a file and you're not sure how many they're going to be. You're reading values from the user and you're not sure how many values they're going to use. For example, give me an average of all these numbers. In the past, we've had to set up sentinels. You know, when you type in a 999, I'll stop now. But if I had to store all those values in an array, that wouldn't work. So we have to declare something called a vector. Now, a vector is really simple. Well, kind of simple. It uses the vector keyword. It has a pair of braces, just like we saw in our static cast. And you have to tell it what type of value it's going to be given. So it's again, just like an array, it only holds one thing. And in this case, we're going to give it an integer value. And we're just going to call it numbers, just so that we're going to store some numbers. So our vector of integer of numbers is now been built for us. But it really is, it's got nothing in it. It's got a size that's kind of limited. As a matter of fact, there is, if you look, if it comes up, there is a size function for this. So I can actually do something like this. I can print that size out. Oh, standard. And if you don't make typos, it works out really well. So right now our vector has a size of 0. To add something to our vector, we have to use some special command words. The command word that we really want to use is called pushback. So you can say to our vector, and it's called pushback. Pushback says add this to the array. We'll talk about pop in a second. And we'll give it a value. So I can actually come in and say, print out that given value. I can print out a value at a specific spot. Now, numbers work just like arrays in the fact that they have that index capability. So I have the same way of going into it and printing things out. So I can do this. So I can see that I have a size 0, and I gave it that. But what happens if I print that size out again after having moved that on? Just for funsies, let's find out. Ah, look, my size went from 0 to 1. I now know that my size, I have one element on there. This allows me to find out what's going inside this thing. There's also another command, by the way, that's called capacity. And if we look at that for fun, you'll see that I have a size of 0, I have a size of 1, I've got a capacity of 1, and I've only added one value, and I'm showing it to you sitting right there at the element 0. But what happens if I add another value? Let's take a look at this just for fun again. Vectors are fun things. Let's say instead of 12, I put in 22. And I'll go ahead and print it out. This gets tedious when you're talking about one at a time, but you'll understand it. Hey, look, I added one more value. I added one more value. So there's 1, there's 2. My size went from 1 to 2. My size is 1. My capacity is 2. My size is 2. My capacity is 2. So 1 and 1, 2 and 2. What happens if I do it again? Let's play. Let's say I add 32 to this. And I come down here and I do the same exact thing. So now, if I do it right, I've added 3 values to it, so my size should be 3. And if you look at it, my size was 1, my capacity was 1. My size was 2, my capacity was 2. My size was 3, my capacity is 4. Here's what's going on. Vectors add by space requirements as you add stuff to it. So the size was 0. If I effectively say, give me one element, it goes, okay, I'm going to double 0, double with quotes around it, to 1. So okay, I'll give you one element. Okay, now I'm going to add another one. Well, let me double the size that I've got. 1 to 2, there's 2. But when you add the third element, this thing doubles the size from 2 to 4. So your size doubles, your capacity doubles. Your size is how many elements you've got inside of it. If I was to add 2 more elements, yes, if you do the math, the size is now going to be 8, but I only have 5 elements in it. So vectors can be, if you're not careful, kind of space intensive. They'll add up a tremendous amount of space very quickly as you add to it. If you're at 128 and you add one more, you now have 256. There's a method that came out that trims things down for us, but that's the concept that goes on with vectors. It doubles the size to stuff more stuff into it. Now you can also declare vectors to have a starting size. So in your case of doing it this way, you would come over here and say, give me it with 4. And that says, give me 4 vectors. And if I come down here and when I run this, you'll see it shows up that way. See, there I go, I got 4. So this number, when you first use it, is the size of it. I can even tell it, hey, I want you to go ahead and initialize everything to 0. Or I could say initialize everything to 10. I could do whatever I want. And if I wanted to print them out, just to show you. Ten and 10. So even though we've been pushing this thing on there, where did it go? Good question. That's a very good question. We have 4 elements. We gave it 10 spots. Therefore, this right here means when we add this on, think about it, where's it going? This fills the vector like a Pringles can. I've put 4 chips on of size 10, and then I drop in and I push another one on. So my capacity is what? Anybody got a guess? Yeah, this is where it gets fun. If we run it, you'll see our capacity now is, woohoo, 8. I gave it 4 and I put values at it. If I actually want to change the value somewhere, I need to tell it where to go. I need to tell it exactly, not to push it on. I have to change a value at a location. So that's a little bit harder to do. That requires you to do this. And there you can see, I went in, the very first one was really right there, number 0 was 10, now it's 22. So the best way to think about vectors really is not to use them like they're an array and size them. I size them only if I know for sure I have at least X number of values to put in, 20 values, and then I'm going to change them or add to those specific 20 values. Then if I get bigger than 20, then I start using pushback. The best way is just to create the vector and let the machine take care of it all by itself until you need to make it faster, better, cheaper. So there's the big things you need to remember about vectors. How do you declare one? Put the type in the braces, give it a name. If you need to, if you know you've got to declare something and initialize it, that's how you do it. Otherwise, leave that part off. Determine the size of something, you might need that. How many spots do you currently have? You might need that. How to individually manipulate each element, that's one way. And there's the other way, using the .at symbol. There's lots more on vectors, and we'll talk about it here in a bit. Hope you're having a great day.